Hi everyone, today we're going to talk about math operations for binary and other numerical systems. Before watching this video, I highly suggest you to go and read my blog on dev.com. The link will be in the descriptions to have a better understanding on this topic and to understand the multiplication, division, subtraction and addition easily. So let's start. So the first thing we're going to talk about is binary addition, and it's actually really similar to decimal addition, and it's really easy to understand. So firstly, let's understand these operations. So for binary numbers, as you know, we have two digits, 0 and 1, and these operations are enough to easily do our binary addition. So 0 plus 0 is of course 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 10, and if you don't understand this part, it will be really helpful for you to read my blog, and 1 plus 1 plus 1 is also is 11. Let's look at this example. To add these two numbers together, we just need to use the usual concept of addition. So let's start from the right. 1 plus 1 is, as we see, is 10. So we write the 0 here and write the 1 in the next column. So right here we'll have a 1 plus 1 plus 0, which is again 10. So we write the 0 and add the 1 to the next column. Again, 1 plus 1 is 10, we write the 0 in the 1 in the next column, and here we have 3 ones, which is 11, so we just write 11. And the addition of these numbers will be 1, 1, 0, 0, 0. If you want to check this, you can just convert this to decimal and see if we did it right. And everything about that is in the blog again. So let's do another example of addition, but this time with hexadecimals, and as we know, it's the same thing as base 16. So the example is a2 plus 3f, and the easiest way to do this is to just convert it to decimal and then back again to base 16 to do everything right. It's the best way. So again, let's start from the right. 2 plus f. So as we know, f is decimal 15, so 2 plus f will be 17 in decimal. And as we know, if we convert it, it will be 11 in base 16. So we write the 1 here and the next one in the next column. So here we'll have 1 plus a plus 3, which is the same as 1 plus 10 plus 3, and it's 14 in decimal, which is, as we see, e in base 16, so we just write the e. And for every numerical system, the addition concept is the same. If you are not getting it, the easiest way is to just convert it to decimal and then back to the base that you want. The next topic is binary subtraction, which is again really easy and very similar to decimal subtraction. So let's start from the right. So 1 minus 1 is 0, of course. Here 0 is smaller than 1. That's why we need to borrow from the next column. And if we have binary numbers and we borrow from the next column, here we'll have 2. So we'll get 2 minus 1, which will be 1. And here we'll have 0 because we borrowed from this column, and we'll have 0 minus 0, which is 0, and 1 minus 1 is 0. So here we'll get the result is 10. So the only concept that you need to consider and be careful is that if we borrow from the next column, whichever base we are dealing with, we'll have that number in the next column. So we had the base 2 and we borrowed from here and we got 2. If it was, I don't know, like base 5, we'll have here 5, or base 16, we'll have 16. That's the only thing that you should consider. Let's try another subtraction, but this time with base 4. So here are the base 4 numbers: 3310 minus 2032. Let's start from the right. So 0 is smaller than 2, that's why we need to borrow from the next column. And as I said, here we'll have 4, so it will be 4 minus 2, which is 2, and here we'll have 0, it is again smaller than 3, so we borrow from the next column. And we'll have 4 minus 3, which is 1. Then here we'll get 2 minus 0, which is 2, and 3 minus 2, which is 1. So the answer will be 1, 2, 1, 2. And again, if you want to check, you just need to convert it to decimal and just check it. It's really easy. The next topic is binary multiplication, and if you understood the binary addition, this one will also be really easy, especially with binary numbers. So it is again very similar to decimal numbers, and we start with the right part. So 1 multiplied with this number will of course be the same thing, so 1, 1, 0, 1. Then in the case of 0, we just write zeros, but starting from this part, so underneath the 0. Then 1 plus, again, this number will be the same thing, 1, 1, 0, 1. So here we have, again, multiplication, and we do the things that I told you previously. So here we have 1, so it will be just 1, 0 plus 0 will be 0, 1 plus 0 plus 1 will be 10, so we write the 0 and write the 1 in the next column. Here we'll have 1 plus 1 plus 2 zeros, which is, of course, again 10. So we write the 0 and the 1 in the next column, and again the same thing. We'll get 10, 0 here, 1 in the next column, and here we just write 10. So the number will be 1, 0, 0, 0, 0, 0, 1. And so basically we just, for binary numbers, the important part is the addition, because I think you won't get the multiplication part wrong, because they're just zeros and ones. Let's look at another example of multiplication, but this time with octal numbers. So they're the same thing as base 8. So the example is 3, 5, 7 multiplied by 2 and 3. So again, let's start from the right part. So 3 multiplied by 7 is 21, but the 21 is in decimal, because in base 8 we don't have that much of the digits, it's just from 0 to 7. So we just converted 21 decimal to base 8, which is 25. So we write the 5 here and 2 in the next column, near the 5. And then we multiply 3 by 5, which is 15, and plus the 2 that we had will be 17. And 17 in the decimal is the same thing as 21 in base 8. So we write the 1 here, and the 2 near the 3. So then we'll have 3 multiplied by 3 plus 2, which is the same as 11 in decimal. And if we convert it to base 8, we'll get 13. So we just write the 13 here, because we don't have any numbers here. And then we write the plus sign and start multiplying number 2 by this number. So we'll have 2 multiplied by 7, which is 14 in decimal, as we see here. And it is the same thing as 16 in base 8. So we write the 6 here and the 1 in the next column. Then we'll have 2 multiplied by 5 plus 1, and this example we had, this is 11 in decimal, which is the same 13 base 8. So we write the 3 and the 1 in the next column. So the last thing that we'll have is 2 multiplied by 3 plus 1, which is 7. So 7 is actually a base 8 number, so we don't need to convert anything. We just write 7 and then do the addition. So only 5 is of course 5, 1 plus 6 is 7, 3 plus 3 is 6, 1 plus 7 is 8, in decimal, which is the same as 10 in base 8, so we write the 10. So in every multiplication, addition, and everything, we just use the same concepts, but if it's hard, we just convert it to decimal and everything gets pretty easy. The last topic is division, and the first example is binary division. So here we want to divide 1011 by 101. So we write it like this, and this part will be the quotient, and if we get anything in the end, so in this case 1 will be the remainder. If we get 0 here, then we don't have any remainder. So let's start by the division. So we start comparing the first number by our divisor, and 1 is smaller than 101. That's why we need to write 0 here, because we only have 0 and 1, and we can't write 1 here because 1 is not divisible by 101. Then we subtract that 0 from 1 and we get 1. Then we put near the 1 the 0, so the next number, and here we have 10. Again, we compare this 10 with our divisor, and we see that it's smaller. So what should we do? We just need to write 0 here and subtract that 0 from here. So we'll have 10 here, and when we put the next number, which is 1, next to the 10, we'll get 101. And when we compare it with our divisor, we see that they are equivalent. That's why finally we can write a 1 here, because 1 multiplied by 101 is 101. And then we subtract that 101 and get here 0. And when we put this 1 near the 0, we see that 1 is smaller than 101, and we don't have any numbers left to just put it down. That's why the 1 is the remainder here. And at the top, so the zeros from the left, they don't count. So the quotient will just be 10. So the concept is the same as we do with decimals. Just the thing is that here we can, of course, only use zeros and ones. And if the number is smaller than our divisor, we need to write here 0. And if it's bigger, of course, we need to write 1. That's the things that we should consider. So the last example for this video is again division, but this time with base 5. So let's look at our example. We have 134 divided by 4. So the easiest way to do this is to have a table of multiplications. So in our case, we have 4 and all its multiplications. So 4 multiplied by 0 is 0, 4 multiplied by 1 is 4, 4 multiplied by 2 is 8 in decimal, which is 13 in 5 if we convert it, 4 multiplied by 3 is 12 in decimal, 22 in base 5, 4 multiplied by 4 is 16 in decimal, and 31 in base 5. So let's start doing the same thing with our division. And firstly, we compare the first number, which is 1, with 4. So as we see, 1 is smaller than 4. That's why we write here 0 and subtract the 0 from here. So we'll get 1 here, and when we put down the 13, we see that actually 13 is bigger than 4, and we can have 2 4s in our 13. We can see that here. So 4 multiplied by 2 is 13. That's why we write here 2 and subtract 13 from here. We'll get 0, and when we put down the 4 and compare it with 4, as we see they are equivalent, and 4 multiplied by 1 is 4. That's why we subtract the 4 from here. We get 0 remainder, and we write here 1. So the quotient will be 21 and the remainder will be 0. So congratulations, now you can do addition, subtraction, multiplication and division with basically any numerical system, because for every numerical system the concept is the same. If you just think for a bit, you'll definitely get it. So thanks for watching this video. Again, I want to mention about my blog post on dev.com. The link will be down in the description, and thank you for your time, and bye.